Atlas has 13 plus documented anomalies that defy natural explanation. This series covers them all before Atlas makes its closest approach to Earth on December 19th. Each episode breaks down specific mysteries that have scientists questioning everything we thought we knew about interstellar visitors. By the end, you'll understand why this changes everything. Subscribe to follow the complete series before Christmas. Let's jump right in. Atlas has 3 trajectory anomalies. Each one is statistically improbable. Combined, they create odds in the thousands to 1 against natural occurrence. And they all point toward one conclusion: this path wasn't random. Atlas arrived aligned within 5 degrees of our solar system's ecliptic plane, the flat disk where all planets orbit. Random interstellar objects come from random angles across the entire sphere of the sky. The probability of hitting our planetary plane this precisely by chance is 0.2% or 1 in 500. That's the first impossibility. The timing is the second. Atlas approached Mars, Venus, and Jupiter while hiding behind the Sun from Earth during perihelion, the moment when it was most active and most observable. That specific configuration requiring Earth to be on the opposite side of the Sun, while Atlas visited multiple other planets, has a probability of 0.005%, or 1 in 20,000. Navigation systems aim for this kind of timing. Random cosmic debris doesn't achieve it. The third impossibility is the Jupiter encounter. On March 16, 2026, Atlas will pass Jupiter at 53.445 million kilometers, matching Jupiter's Hill radius, the exact boundary where deployed satellites can maintain stable orbits within measurement error. The Hill radius at that moment will be 53.502 million kilometers. The match is within 1 standard deviation across Jupiter's entire orbital diameter. Hitting that specific distance has a probability of 0.004% or 4 in 100,000. Here's what makes this devastating. That precision required the non-gravitational acceleration measured at perihelion. Without that course correction, Atlas would have missed Jupiter's Hill radius. JPL originally calculated the match, then revised their model after Loeb published the coincidence, changing from a water ice sublimation model to a CO2 model that conveniently moved Atlas just outside the Hill radius. But the new model contradicts brightness observations, showing Atlas got brighter near perihelion than the smooth CO2 model predicts. Someone had to aim for these configurations. The ecliptic alignment optimizes planetary visits. The timing maximizes observational coverage while hiding the critical perihelion moment. The Jupiter distance matches the deployment zone where satellites require minimum fuel to maintain position. Multiplying the probabilities brings 4 in a trillion chance that all 3 trajectory features occurred naturally in one object. Why does it matter? Random objects don't thread needles across light years of space. Navigation systems do. Before Atlas passes closest to Earth, you need to understand these odds. Drop a comment. Which trajectory anomaly surprised you most? The ecliptic alignment, the timing, or the Jupiter match? Next up in the Atlas files, the chemical mysteries, industrial ratios, and organic molecules that don't match any known comet. Watch the playlist, Atlas Anomalies,